last video, we put numbers on the shape of a distribution. Now we make the picture. And the second plot here is one you'll use almost every remaining week of this course. Same setup, and I'll open plots and tick histogram. There's age. And immediately the bars are touching. Our bar plot of race had gaps. That was deliberate. Gaps mean separate categories. Touching bars mean a continuum, because age doesn't stop and restart. Shape. Broad. A peak in the younger middle range, trailing off to the right. Compared to last video, skewness plus 0.435, mildly right skewed, and kurtosis minus 0.750, flatter than normal. Picture and numbers agree. I'll add density, which lays a smooth curve over the bars. Same information, less noise, often easier to judge. Education is a completely different animal. One enormous spike at 12, a high school diploma, 18,000 people. A smaller spike at 16, a bachelor's degree. Then a long, thin tail down to the left. That's the picture behind kurtosis of plus 1.070 and skewness of minus 0.380. Same story, told two ways. And here's a bonus observation worth putting in a lab write-up. That distribution is lumpy for a real reason. Education gets credentialed in chunks 12 years and 16 years aren't just numbers. They're a diploma and a degree, so people pile up there. When a distribution has spikes, ask what's causing them. There's usually something real underneath. Now the important one. Q, plot. This looks strange the first time. Here's what it does. Jamovi takes your data and asks if this were perfectly normally distributed, where would each point sit? Then it plots what you actually got against what perfect normality predicts. Every dot is one of those comparisons. The diagonal is perfection. If your data were exactly normal, every dot would sit on that line. So dots hugging the line means approximately normal. Dots curving away systematically means not normal, and the way they curve tells you how. Age. Through the middle, the dots track the line closely. At the ends, they pull away. That's the flatness we measured. The tail's not reaching as far as normal would predict. But this is a good-looking QQ plot. If someone asked whether age is approximately normal here, I'd say yes. Education? Very different. You can see a staircase flat runs of dots at the same height, which is all those people stacked at exactly 12 and 16. And the low end bends away, which is that left tail. So, age approximately normal, education clearly not. But notice it isn't wildly off through the middle either. That nuance is normal. Real data is rarely perfectly normal and rarely catastrophically non-normal. Usually you're making a judgment call, and the QQ plot is how you make it. Why this gets its own video? Starting in a few weeks, tests and ANOVA come with an assumption of approximate normality, and you're supposed to check it every time. 2 clicks, descriptives, plots, QQ plot, and you can say something defensible about whether your data meets it. 30 seconds, that pays off for 10 weeks. Recap for the week. Bars touching means continuous. Bars apart means categorical. Histogram and density show shape. The QQ plot speaks to normality, and it should agree with your skewness and kurtosis. When they disagree, go find out why. That's usually where the interesting thing is.